Everyone enjoying the conference so far? We're just looking forward to the party. I see some of you already have gotten your beers. I'm really jealous. They told me I wasn't allowed to grab a beer here on stage, so I'll wait. So we're going to talk about some successful code-sharing principles for mobile development. How many of you are doing Xamarin? Most of you are doing Xamarin. That's great, because we're going to talk about Xamarin and how we can build better apps when using Xamarin as a technology to target all these different platforms. So I've been working with Xamarin for a really long time, and I find that I always struggle to appropriately architecture my apps so that I make it easier for me to share codes across the platforms. So I'll talk about a few things in this talk here around how we can make it easier for us as developers to share more code across the platforms, and some of the pitfalls that we might fall into. And I tend to do all these things incorrectly a lot of the time, so I'll talk about this from my perspective and things that I've learned when failing to build apps. So before we do that, let me introduce myself. I'm Filip Ekberg. I'm a C#, or actually I'm a Microsoft and Xamarin MVP. Pretty much means that I go around to conferences and talk about all these amazing technologies. Doesn't really mean that I know how to build an app. I just talk about how to do it, but I leave the building apps to everyone in here. So what I'll do, since there's so many handsome people in here, how about you snap a photo of sometime in this talk, you tweet that, and I'll give you a free copy of my book, the digital version. Sounds fair? And also remember to put a green thing in the box. That'll make me really happy. All right? So now that we got that out of the way, let's talk about successful code sharing principles. The idea of sharing code across the platforms can really seem easy on the paper, but when we start building these Xamarin apps, it can start to grow in the platform-specific projects, and we end up having code bases that are really fragmented across the different platforms. And we just want to make sure that we can take our code base and make the best out of it. So I was thinking about this when I started preparing this talk, and I think a more appropriate title for this session is more or less how to build unsuccessful apps. Because from my point of view, I try to build the best apps possible, and I try to apply some patterns and principles to make it easier for me to do that. But even if I use these patterns and principles, I end up sometimes failing to share a lot of code across the platforms. And most of the teams that I visit and talk to about Xamarin, I see the same patterns and behaviors, that we fail in sharing code across the platforms because we try to focus too much on actually building an Android app or an iOS app, and we don't think about what's common between these two apps. So for those of you that don't know what Xamarin is, the short sales pitch is that we're allowed to build an app that's runnable on pretty much any platform. We get a native binary that allows us to access all the native APIs. We get native performance. But that also means that we need to learn about the native platforms. It sounds like the room next to us is having a lot of fun. They're just cheering for me. They're watching the live stream. That's what's happening there. All right. So Xamarin is all about allowing us to build apps for all these different platforms, right? And it allows us to do that by splitting it all up into nice little boxes. So most of you have probably seen some of this before. So we have these platform-specific projects that allows us to build the app for iOS, Android, and maybe Windows, and hopefully in the future even like a toaster or your refrigerator or whatever we want to build the app for. As long as this allows us to build an app for that platform, we can probably use Xamarin for it, especially if there's a UI. So the promise is that we can share a lot of code across these platforms in this shared application logic layer. And we do that by introducing PCLs and shared projects, and maybe we get a NuGet package into our solution to make it easier for us. So this talk isn't an introduction to Xamarin. It's more about how do we go back to the basics and learn about the patterns that make it easier for us to share code across the platforms. And what I find happening in the apps that I normally work on is that we end up with an architecture where there's a larger portion of iOS code, and maybe there's a little bit less Android code, and the Windows one is pretty much non-existent, unless we have a manager that owns a Windows phone, because then we need to build a Windows app, right? But sometimes what might happen is that we have an iOS developer that's very keen on building things for iOS and knows all about building widgets and all the cool things you can do in iOS. And then maybe we have a C# developer that just learned how to build an Android app, and they don't know how to do all the cool things on Android. So that means that we do a lot of work in the platform-specific layers. So what we want to end up doing is kind of avoid putting too much code in our platform-specific projects. So normally, me myself, I feel the urge sometimes to just add things into this platform-specific layer or code that's not shared across the platforms, just because it's easier. Sometimes it feels like I'm taking a task to start building a new view in my app, and I start building that for one of the platforms. And then when I go on to the next platform, I build it again. And I don't go back and look at the code that I just built, rather than just, breaking that code out. So are you all familiar with the red, green, and refactor practice? So you build a test first, like in test-driven development. The test fails, you fix it, and then you refactor the code. So I'd say that we apply the same principle here, that if we start building the UI for Android, when we go to iOS and build the same UI there, go back and look at what we built for Android. Break out the common things for the UI logic, right? What happens when I click the login button? The logic, if this person has entered a username and password, that's the same on all the platforms. So we can make use of these really simple practices to make it a lot easier for us. So if we take a look at a current state, this here is going to be an application that I started out of Visual Studio for Mac. So I simply set up a totally blank application. And this application is allowing me to build an iOS and Android app. It's built by using a shared library, which allows me to write code that's accessible on all these different platforms. Now, since this is an out-of-box application, you'd think that they applied all the best practices, right? Well, if they did, I probably wouldn't show the code, right? So we have this code example here. It's an Android application and an iOS application, and then we have this shared project up here at the top. Now, the shared project is a way for us to share logic across these different platforms. A shared project is simply a way for us to say that, well, when this compiles, bring in all the files and compile that as a part of our project. That gives us the capability of building code in one place that compiles for that particular platform. So for instance, if we're using SQLite, I want to have access to a database. I want to have the common pattern of a repository pattern. I build that inside my shared project. And then I tell my iOS project and Android project to bring in the libraries for SQLite. And then my shared project is just going to know how to talk to SQLite. That's super simple, right? So that's the idea of a shared project. And what we can see in here, what they've done is that they've broken this up into smaller pieces, which allows us to follow a pattern called MVVM, even though the native platforms like iOS and Android aren't really using those patterns if you work in Java or Objective-C. But the idea here is that we take that UI logic, we bring that into the shared code, so we have these things called view models, right? So we'll get into that a little bit more later on. But looking at this structure here, it feels like, well, this is the holy grail of the architecture of an app. Most of us probably don't work in an application that's layered like this here. I know that I've been in a lot of projects where this has been like the goal to reach this shared code here. So most of us might work in projects where there's a lot of code in our native projects. And the idea here is that they've built an iOS app. This is an Android native and native iOS application. They've rebuilt the UI for each platform, and then they simply broke out a little piece of the UI logic and put that in a shared project. But most of us might not have that luxury. We might work in applications that have a lot less shared code than this here. So the reason that I'm showing this example here is because it would probably be pretty hard to follow a demo where I wrote a lot of crappy code, right? Even though I probably write crappy code pretty easily, it would probably be hard to follow. So the idea here is that we use this shared project. And things like, if we look at one of the activities here, we'll see here that in this activity, all they've done is that they say, well, if you're logged into the app, I want to show this screen here. If you're not logged in, go over here. So I find it that, well, why didn't they apply the same principles here? Because this part here is something that's probably common between both iOS and Android, and would be common if we built this app for Windows as well. So this is where I find that, well, I as a developer might find the urge to add this type of code, because it's just a few lines, right? But I start adding these few lines for each platform, and then, well, what happens if, well, we need to go in here, and when you're logged in, I also want to, add something to the database, and then I want to ping Google Analytics and so forth, right? So this thing here starts to grow. And this is where we start to have a little bit of problem. So once we start not breaking out our code, even though it's small samples, we need to think about how we can make it better if we want to expand on the code later on, right? Because all of this could grow out of proportion. All right, so this is the current state of the app. Let's just run it and have a look what it's currently looking like. And we'll add a few patterns and practices to this app throughout the talk, and we'll see how we can make it better and how we can add patterns and practices to make it easier for us to add functionality and do it more testable and maintainable. So here it's now running on our Android emulator. I can click here that I don't want to log in. It'll bring up this app here. And this here looks like a beautiful app, and hopefully they've shared a lot of the logic. Like, where do we get these names from? How do we add things? What's the data store? All of that is hopefully shared code, right? So let's just have this as our current state. Our application is pretty good, but we know that we can make it even better. So let's start to talk about how we can do that. And the reason that I'm talking a lot about why there's a problem with the current app that we're looking at here, and the reason that we talk about how hard it is to share code is because that's a really good way for us to understand the difficulties in code sharing appropriately across these platforms. So why is it so hard for us to share code across the platforms? You know, this thing here might seem a little bit impossible to solve, and so is code sharing. The reason that it's so hard for us to share code across the platforms is because iOS and Android and Windows Phone and HoloLens and all of those different platforms are totally different, right? But then if we go back one step from the UI and think about, well, there's still some logic happening on all these different views. We have different representations on all these different platforms. We might have the Surface Hub, which is an 80-inch big monitor that allows us to do touch on the screen. That one might have a particular UI. But if we think about how we approach the problem, which is the app that we're building, we might find that we can follow some common practices across all the different platforms. So if we're working with HoloLens and, you know, the Android Watch and iPad, they might have different UIs, but then again, they might have the same logic behind that UI. So even though it might seem like it's a very hard way or easy way in this case here to find our way through this maze, we know that when we start the project, we're going from point A to point B, and we simply want to get out of this. In any given project, we face problems, we need to go back and take a different turn to make it easier for us to build the app. But when we're building mobile applications, what I find happening quite a lot is that we end up with a maze pretty much looking like this here. I don't even know where the end is. So this might be a little bit difficult for us to simply solve. And there's so many different paths that we can take when building apps. As an example, when we're building Android applications, do we build the UI using Android XML? Do we go into the activities and simply build up all the controls ourselves? So it might seem a little bit easier to just build it using Android XML. So let's jump over to iOS. How do we do it on iOS? Well, we can use nib files. We can use storyboards. We can use code behind in our view controllers. And I promise you, I've seen projects where we do all of them at once. We have some nib files over there, we have some storyboards over here, and then we have some code here in our view controllers. But that's UI code, right? But we also, in that case, if we have a bad architecture for the UI, we probably have a bad architecture for how we share code across the platforms. So when we're working with Xamarin, it's all right to feel like this sometimes, especially when we're building apps. Because remember, we try to target so many different platforms. We try to build an app that works really well on Android, iOS, Windows, HoloLens, and our watches, and all of those different platforms. So, you might find yourself wanting to add a little bit more code to the platform-specific layers. But if we think more about how do we solve this for all the platforms, that's when it starts to get interesting. So we've talked a lot about now what the problem is. But how do we solve it? How do we make sure that our apps can be better and that we can share more code? So we can do abstractions. Now, I'm not going to jump around like Steve Ballmer and screaming abstractions, 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 even though that would probably be a bit funny. But what happens here is that we can introduce abstract classes, we can introduce interfaces, and we can make sure that we can share more code across these platforms. We can go back to the basics and look at patterns and practices that have been around for a long time and just think about how do we apply this in Xamarin. Now, I know dependency injection and inversion of control might not be available if you work in Java on Android out of the box, but we can still use frameworks to allow us to achieve the same thing. So one thing that I find happening when we do this, so I want to introduce a shared project. And one thing that I find happening is that we end up in a situation looking like this here. So as I mentioned, we might have UI code and storyboards and nib files for iOS, and then we have something different for Android and Windows. And then we try our best in building these shared layers. We have a shared project that compiles for all the platforms. And then inside this shared project, I just want to do something specific for a particular platform. On Android, I might want to do something different when I talk to the key store or keychain, right? So then what happens is that we leak information about our platforms inside the shared projects. And then we're back at square one. So what happens here is that we try to build UI-specific logic inside the shared code. Our shared code logic layer grows, but that doesn't mean that we shared more code. So we end up in a little bit of a mess here as well. So we'll look at how we can avoid this as well. And one way to achieve the goal that we want is by looking at introducing different layers. So we can introduce a native layer, which is the iOS, Android, Windows app. Or if you're developing applications for the Samsung TVs, you can introduce a Tizen app. And then we have a shared UI layer. I'm not saying that the Salmon Forms is the answer to everything, but we'll look at later on how we can introduce Salmon Forms as a small part of our app where it makes sense. So we can try and share our UI, but we also, in that layer with the shared UI code, we bring in the view models. So view models is everything from what happens when I click the login button to how do I display this pop-up when something happens, or how do I communicate with the UI. All of that lives in a view model. And then we have shared logic, which could be a different shared application layer. And inside this layer, we could have things like, how do I talk to SQLite? How do I do a repository pattern? We can leave that in that project there. Because if we have a PCL then that's maybe shared by our ASP.NET backend or an old Windows Forms application or any other type of .NET app, they might bring in interfaces and abstract classes that we want to use inside our code. Right? So if we bring in an interface in a PCL, then we can build the implementation for that either in the native layers, or we can do that in our shared logic layers, if they're similar across all the platforms. So I'm not really saying here that more layers is going to be better, but I like to divide my applications into these 4 different pieces, because it kind of forces me to think more about where do I put my code for all the platforms. Of course, I can go into the native applications and build things into the Android app and the iOS app. But if I layer it like this here, it becomes a little bit easier for me to appropriately approach this using 1 or 2 patterns. So there's plenty of patterns that we can use to solve these different problems, right? We can use inversion of control and dependency injection. We can use a service locator. We can use a bunch of other different things that I could just name drop, right? But just adding a pattern doesn't solve the problem. It might just make it a little bit harder. So I've seen projects where we add patterns like service locators to make it easier for us to not have to worry about creating new classes and injecting dependencies and so forth. And we'll look at that as well soon. But you can end up shooting yourself in the foot even if you do that. You can end up over-engineering your architecture as well to make it even harder for you to share code. Right? So why do we want to do this? Why do we want to bother just not doing it like we did before? You know, if we want to build an application in C# and we don't really care about code sharing, like why do we bother using Salmon at all? If we just want to build an app, why not just hire a Java developer or iOS developer? The idea here is that we can add more platforms and access more APIs as they are available. So the code that I showed you earlier, how do we test this? Like if we think about testability and maintainability, how do we write a test for this here? Now, if you're an Android developer, you probably cringe a little bit and you think to yourself like, well, you don't really write a test for an activity. But I want to test this part here saying, well, if you're logged in, if there's something telling me that you're logged in, something's going to change in the app. In this case here, it's just a transition, but it could also be try to write this thing to the database. If it's not logged in, it might terminate the app. Like, I want to find that out. I want to write a test that tells me that this code here works. And do that here is kind of hard, right? Because this here acts as either it's a static thing or it's living as a property on the class. It's just hard for me to write a test for that. So the way that we solve this is by decoupling the app. And I kind of just mentioned this, that we could break it out into things like a view model. But how do we do that and what would that look like? Decoupling our apps means that we take some of the dependencies that we have. In this case here, that we have this settings thing here, which is a really hard dependency on something that we can't really control. And this here, I think, is breaking some of these solid principles as well. So what we can do is that we introduce these patterns to decouple our applications and make everything loosely coupled. An example is, how about we introduce a view model? Now, this is a lot of code to simply get rid of that if settings is logged in thing, right? But as I told you, this could grow out. This could mean that we can now write things to the database. We can access things in here that we maybe didn't want to do in the native code. So the idea here is that, well, if you're navigating to this page here, we run this onNavigated-to function. And then this thing here checks if the setting is logged in, but this here points to an interface, which means that I could inject that if I wrote a test, right? Makes it a lot easier for me to test this logic. And then, of course, I can use things like an event aggregator or the messaging center, which we'll also look at in a bit, to tell the native project that, well, something's going to happen now. And then all that we need to do if we introduce a new platform would be to subscribe to the different events. We'd have to go in here and say, well, if you now get this I'm logged in completed event, what do we do then? So we don't want to over-engineer the apps, but what we could also do in here, which would even greatly improve this here, is how about we inject an iNavigation up here? Then I could say down here that, well, just use iNavigation to navigate to that particular place. And I've decoupled the navigation as well. So that's pretty cool. So how about if we really want to run platform-specific code? There's a lot of cases out there that kind of forces us to talk to the native APIs. We use Xamarin because we want to get the native performance and get access to all the native APIs. But how do we do that if we're doing everything in shared code? So I'm not saying that we want to approach 100% code sharing, because this is not Cordova or PhoneGap or whatever library out there that shares all the code. This just allows us to build a native app that performs awesomely, and it allows us to access all the API where it's appropriate. So we could think about NFC, for instance. So Android has had the capability for forever, pretty much, to be able to talk to the NFC chip. So a funny story about that is, I don't know how many of you saw the Apple event and Apple keynotes. They just released the capability for us to talk to the NFC chip. But what they did was that they only allow you to detect if you're blipping against that tag. And that's pretty much useless. Most of us want to be able to take our phones and blip that to something, and that terminal that we were blipping our phone against, we want that to detect that we did that with our phone, right? But we're not there yet on iOS. But when we're building the apps, we want to say that, well, we have this shared code that knows how to talk to NFC. If our app does both reading and writing, we just toggle it for iOS. We just turn one of them off. And then when it's available on iOS, it should be super simple for us to just turn it on. Right? So how do we do shared code, but we want to be a little bit specific? So one thing that we can do is that, in this case here, this is an example from a code base that handles an HTTP message. So all that it's doing is that we are requesting some gzipped information to make sure that we transition a little bit less data over the wire. So we want to make sure that we compress all the data that's passed to the app. But the problem is that Android doesn't support, or at least through Xamarin, the libraries don't support gzip out of the box. So we need to manually decompress our content, which is a bit nasty. But we still need to do it. But it wouldn't make any sense for us here. So we can say, if it's on Android, I want to run this decompress method. And then we decompress all the data, right? So it wouldn't really make sense for me here to break this out and build that thing inside the platform-specific layer. I could just do that in my shared code. So sometimes it's appropriate for us to break out. Remember I talked about earlier that we get this idea of we have a shared project layer, but then we kind of leak platform-specific implementations. This is one of those cases, but in this case, it's fine. So it's really hard to make the distinguish between when is it okay and not. But if it's just a few lines of code that's different for one platform, I think it's okay. We could have solved this by injecting an interface. We could have, but this is all right as well. So if we want to take this one step further, we want to use patterns that allows us to inject platform-specific implementations. And one way to do that is by introducing something like an IoC container. So tiny IoC is a way for us, it's just a CS file. You bring it in from GitHub, you compile this as a part of your project, and it allows you to register implementations for certain types. So what's pretty cool here is that I can say, well, I have an account service that implements the interface iAccount service, and then I have an iPreference service, which is implemented by preference service, and then the cache as well, right? And the cache here is marked as a singleton, which means that you'll always just get one instance. Right? So I can configure this a bit to be accustomed to my needs. And what's cool here is that maybe the account service takes a preference service that takes a cache. And what happens when I ask this container here to give me an iAccount service, it'll just automatically create the instances for all these different types. So it's just simple inversion of control. Right? So this makes it a lot easier. And then we can introduce a pattern called a service locator pattern, which is pretty much an anti-pattern because it doesn't really make our code easier to test. It makes it a little bit messier in my point of view, but it's available to us to use on all these different platforms. And it's pretty much the only way that we can do dependency injection on Android and iOS, at least that I know of. So what I'm doing here is that I'm saying, well, when you use the service locator and you ask for this account service, it's going to use this tiny IoC container to resolve that type, which means that it's going to create the cache, it's going to create my preference service, it's going to inject that into the constructor, and then give me a full-blown account service. So let's look at how that works, and maybe why it's making everything a little bit harder to work with. So I have the same app that we just looked at. I'll just stop this here so we get the solution. And what's happening here is that inside my Android project, we'll go into our splash screen activity. We'll see here that I'm using the service locator to get an instance of this account service. And then I can use my account service to create and save a new account called demo. I inject some properties that I have on that type. So this thing here, if we look at the account service, we'll simply see that we have this contract here allowing us to set the identifier for the account and then inject a few properties. Super simple. But then what we can do here is that we can use this here in our splash, and then somewhere else in my Android app I can request this thing as well. So if this is a repository, or in this case it's a service, I imagine that it doesn't matter if it's a singleton or not, it's just going to go ahead and grab me the data from some storage. So if I'm going to our login activity here, maybe you saw this earlier when I pulled up the application, it said login as Filip. And that's because what happens here is that inside the login activity, I also say, well, give me the service. And I can load my demo account and then show the account name. So, if we start the app, we'll see here that we get the instance of the iAccount service. It uses that to save something, and then when we are inside our login activity, we get the same data. So this is a way for us to kind of decouple that thing, right? And then the implementation of this account service can live wherever. Maybe the implementation lives in a platform-specific layer, because frankly, what I could do here is that I can say, well, I want to use the service locator, the service locator.instance.register, and this here would allow me to register any interface towards any implementation. So if I'm running this on Android, if I'm running this on iOS, I could inject platform-specific implementations. So this is a way for us to work with the contracts within our share code and our PCLs, and then inject that from the platform-specific layers. And one thing that we'll see here in this application is that there's something called the app.cs file. The application.cs file kind of bootstraps the app. It sets all these dependencies up when it starts. So this is being called inside our application delegate, and on Android we have an application that's starting this up. So what it's doing is that it's registering all these types with our service locator. And we can see here at the bottom, since this is a shared project, it's saying, well, for iOS, I want you to register the iMessaging dialog as an iOS.messaging dialog, right? These two different lines could have lived inside the platform-specific layers instead, if we wanted to do that, right? So the service locator pattern allows us to to get our interfaces and have them in PCLs and in shared projects, and then we can inject those implementations from those platform-specific projects. And of course, we could, inside our PCLs or inside the shared projects, we can work with those interfaces and those contracts. We don't have to care about the actual implementations. So that's one of the things that you need to think about. But the problem with the service locator pattern is that, well, sometimes you can feel like, well, what have I done? Because you end up using the service locator pattern everywhere, and when you call a method, you want to be very explicit about what that thing is doing. And if it's simply asking for implementations of something, it's still going to be impossible to write tests for it, right? It's not impossible, but it's going to be really hard, because you need to register those things inside your test project in order for you to be able to run the tests. So imagine that we have a method. We just call it, let's call it load. We call load in our test, and then inside our load method, it uses a service locator to get our iAccount service. But we don't know that when we call this method. So we need to think about when we are actually using the service locator pattern. But then we want to go back to thinking about, well, I don't want to repeat myself. And especially when I tell myself this, I add the idiot part, because I tend to repeat myself quite a lot. So we want to make sure that we're not repeating ourselves in our platform-specific layers, right? So we can use the service locator pattern to bring out the interfaces and contracts and put that inside our PCLs, but that's just a small part of our code, right? One of the things that I've found lately is that, well, I want to stop re-implementing the UI for each platform. How many are using Salmon Forms? Yeah? Is the rest of you using Salmon Native? Maybe? So Salmon Forms is really great, but the problem with Salmon Forms is that up until now, you've had to choose, well, do I build an app using Salmon Native, or do I build an app using Salmon Forms? So if we're working in a greenfield project, which is a totally new project, we can do and choose whichever technologies we want, then maybe we choose Salmon Forms. But maybe we don't, right? It really depends on what type of application we're building. But what's really interesting is that now we can kind of use these technologies together to make it easier for us to share even more code. And yes, this here, if you recognize this background, this is from Windows XP. But I'm not saying that Windows XP is the best project in the world to look at, but it's a nice background. But if we work in a greenfield project, everything looks like these blue skies and, big green field that we can just run over and everything's paradise. Most of the time, though, I don't know about you, but personally, I end up working with spaghetti code. And most of the time, it's my own code that I wrote last week. I still feel like I don't know what I wrote. But sometimes you jump into projects that someone else built. Maybe you had an iOS developer building the Android app using Xamarin, and they tried to implement everything like it was an iOS application, right? So taking over someone else's code might seem like a bit of a struggle. So we want to make sure that even if we get into these really bad applications that are really badly architectured, we can use things like the service locator, we can do things like event aggregation, and using version of control, and bring things out of our platform-specific projects for new things. And what we can also do, as I just mentioned, is that we can introduce Salmon Forms. So the idea here is that, what about if we take Salmon Forms and we simply inject that into a little part of our application? So imagine that you take over an application from someone else. And I've done this recently. I've worked on an app that's built using Xamarin Native. And we want to introduce a few different screens in the app that simply gives the user some extra information. It just asks for some input. It's not really the most graphical application or the most graphical using the app. We don't need the full GPU power or whatnot. So we could have used Salmon Forms. We don't have to repeat ourselves when it comes to the UI. So what you can do is that you can use something called Salmon Forms embedding, which allows us to build forms views and then just use them as fragments or view controllers inside the apps. And that allows us to do even more cool things. That allows us to share more code and allows us to follow these best practices. We can do things like dependency injection in Windows Forms, which you cannot really do on iOS and Android. So you can use the dependency service, you can use the messaging center, you can use all the navigation that comes with Salmon Forms. And when we do this, we kind of embrace ourselves to build better apps and more easily architecture these types of apps. And I think maybe what happens here is that we still leak into our share code because we try to write a lot of UI-specific code inside the shared project layers. As I showed that little part that it registers the iMessaging dialog for iOS and Android, I've seen places where those just grow out of proportion. So in an ideal scenario, what happens is that we try to we introduce this UI layer here, and the Salmon Forms layer could be our view models. We can have all the view logic in this layer, and we can clean up our share code. And I think this makes it a little bit easier to work with, hopefully at least. So how do we do this? Well, with Salmon Forms, we can simply create this new main page, for instance. And then we can say, well, give me the fragment, or give me the view controller. And that gives me those things for the particular platform. So in this example here, what we have is that we have an Android activity. We have a login activity, and what it's simply doing is that it's displaying the username and then a login button. All I'm doing here is that I'm injecting this fragment here by simply creating an instance of the page and then saying that, well, you should be displayed here. And it all looks pretty nice, right? And for iOS, we do the same thing. We can say, well, give me the view controller, and the way that we inject the view controller is a little bit different, especially with this demo application, but we can do the same thing, right? So let's just have a look at what this looks like and what kind of possibilities that we get out of this. So one thing that I find is that looking at Salmon Forms is a great way for us to understand how we can do proper code sharing. And looking at how we can share the UI kind of gives us an idea of how do we share the logic. Because fundamentally, Salmon Forms embraces MVVM. And MVVM is a pattern to allow us to break out and loosely couple our applications. All right, so enough talking about that. Let's find the solution. We'll just close all these windows. All right. So here, we're going to look at Salmon Forms embedding. So I have the same application. And what I've done here is that I've introduced a new layer. I introduced a PCL. A PCL is a way for me to write code that's shareable across different types of applications. So a PCL allows me to say that, well, this library is accessible from Xamarin. It's available for Windows and WPF. And I don't know if you can use it in Silverlight, but that's legacy anyways. So what I can do here is that, well, I've defined a page that simply allows me to bring in a button. And when I click the button, something happens, right? Super simple example. This is like the fundamentals and the examples that you get out of Salmon Forms when you just create a new project. So I have this thing here. Just imagine that it could have been a lot more complex. It could have a really complex view that has a lot of nice UI and it's bound to a lot of crazy properties. But what we can do now is that I can go into my Android project and I can say, well, when you click on one of the things in the app, so maybe you saw this earlier that you had this little tab bar that allows us to tab between views. Those are actually fragments. And the way that we can do this is that I told you before is that we can create a new fragment. So I have my main activity here, and it has something called a fragment page adapter. And I'm simply initializing Salmon Forms. I'm creating a new page and then asking it to give me the fragment. That's pretty cool, right? It'll be more awesome when I actually run the app and you see that it works, rather than just looking at the code. So what this allows me to do here is that I'm saying, well, I have this Android application. I have the full power of using Xamarin for Android and the native Xamarin, and then I can bring in a shared UI where it's appropriate. And then maybe I have view models that live in a PCL or view models that live inside my shared project, and I can make use of things like tiny IoC to do inversion of control. I can use Prism to do a lot of MVVM craziness, and I'll show that as well in a little bit. So let's run the app. So, properly architecting these apps is pretty much going back to the basics, looking at how do we write testable code? How do we approach our applications? Just think about that iOS and Android are very different, but the things that we do in the apps, for instance, here we have two buttons. What happens when I click Not Now here should pretty much be the same thing no matter which platform, right? Maybe it needs to check something on the platform, and it could be living inside a shared project. You also saw here that it's taking a little bit of time to get into the main view here now. It's because it's initialized the Salmon Forms. And this here is a very early preview of Salmon Forms embedding. They just announced this on build like a few weeks ago, and it's hopefully available as a stable version later this year. So now we have this page adapter here, and I can see that if I click About here, this here is a Salmon Forms page embedded inside my Android app. And I think this is pretty awesome. And now what I can do here is that all of this code in here can use MVVM, and it can use all those dependency services and messaging services that are available in Salmon Forms. So that just allows us to share even more code. So if we just run the iOS app as well, I'll show you the iOS code first. So the iOS app is pretty much the same thing. I'll start this off and we'll see if it boots up in the background. I already have the emulator here, so let's run that. And on iOS, what's interesting is that it's a lot faster. So when I click Not Now here, it's super fast to get in here. Then I can click About here at the bottom, and you'll see that we get this Salmon Forms page as well, right? It's pretty cool. So it's a way for us to, where it makes sense, share a little bit of the UI. So this is one of the principles that I'm really trying to approach in a lot of the projects that I work on. Because a lot of the time, UI is similar across the platforms, right? Even though it compiles into looking like it's a native iOS app and into an Android app on Android, the structure is pretty similar. So when we run this or create these things on iOS, what we need to do is that I'm doing a little bit hacky here. So what happens is that I create a navigation page, which gave me this navigation bar on top, and then I just create my Salmon Forms page and inject it to that. I set the tint color at the top, and then I simply say, well, give me a create a view controller out of that. And this allows me to then again embed Salmon Forms in my app. And I think this is quite powerful. So allowing us to do this means that we can start sharing the UI. And if we try to approach this using the principles of inversion of control and dependency injection and how do we write testable code, get our UI logic into view models, I think we're off to a pretty good start. So one of the things that I'm trying to do in most of the projects that I work on is to find out what common UI logic do we have on the platforms. So a lot of the times we've built apps that are totally similar on the platforms. The UI might be a little bit different and look different and perform the same on both platforms, but we've duplicated all the UI logic. And that doesn't really make sense, right? So one of the things that we can do is that we can now, if we use Salmon Forms and bring that into our solution, we can use something called a dependency service, which is kind of like the service locator pattern, but it allows us to register types a little bit differently. So here I can say that, well, I have this account service that lives in a PCL somewhere, and this here is in fact implementation. And then we register that in our entire assembly by just introducing that thing at the top there. So what then happens is that I can use the dependency service like this here to access this dependency anywhere. So imagine that I have my Salmon Forms project, and inside my Salmon Forms project, I can say, well, give me the iAccount service, but the Salmon Forms project has no idea about the Android or iOS project. So this is where we start to get separation of concern, right? We have our interfaces in a PCL, we have our UI in the Salmon Forms project, we have our implementations living somewhere, and it's all starting to get pretty good. But then you probably think, well, I've got the login button in my app, for instance, that I showed you earlier, or the increase numbers button that we have. How do we notify Android or iOS that something happened? How do we communicate back to the native layer that something's going on? We can use event aggregation, or in Salmon's case, it's called the messaging center. So fun fact here is that the current version of the messaging center has a bug, so it doesn't really work well on iOS. But what's pretty cool is that when you create a new project with Xamarin, if you use the Xamarin native project structure, it'll actually give you a messaging center implementation that works, because it kind of built that for you. I'll show you that in a bit. But what happens here is that I can say, well, when I click login, I want you to send a message back to the native layer. And that's using event aggregation. So that's a way for us to separate our concerns and loosely couple the apps. So an example of how we actually implement this is by, in this case here, I'm simply registering for a certain event. So I'm saying here, well, when there's an event from the login view model, and the event is login completed, I want you to run this particular code. And then what happens inside Salmon Forms is that I can say, well, just send this event here, and whoever listens for it can do whatever they want. And this here also allows us to, well, we can abuse this here, because this allows us to cross-communicate wherever we want, right? You might have a view model that listens for this event, and you might have a view controller, you might have something else listening for it, and then you just have events raised all over the place. Can get a little bit tricky to debug, but it allows us to write more testable code. So let's look at what this looks like. Let's make use of the dependency service and the messaging center, which allows us to write more shareable code. So pretty much the same solution. And we have a project that allows us to do these things. So in this project, inside my Salmon Forms project, I have a new view here. And of course, when using Xamarin, I can use Salmon Forms, sorry. When I use Salmon Forms, I can use SAML. So here I have a view here that allows me to click a button. And when I click that button, I'm going to raise or run a thing called the login command, which is then inside my view models, right? So I'm using MVVM, and I'll show a little crazy demo in a moment of that. So what happens here is that we're simply saying, well, I want you to give me the iAccount service dependency. So here we're asking for a dependency using this dependency service. And this thing here, like Salmon Forms has no idea about where the implementation of this is. If I F12 into this here, we'll see that, well, this is just the interface. It's implemented somewhere else. So what I'm doing here is I'm saying, well, give me the implementation and then save a new account using these preferences. And then we'll go and send a message using this messaging center, which I've brought into the app. We don't have to go through the code here. But this is simply allowing me to send messages to whoever calls or subscribes to a message. Pretty simple. So I'm saying here, send a message from the login view model, and then we send the event login completed. And then if we take a look at what we have in the Android project, we can have a look at one of the activities that is using this here. And I had to add a login fragment activity here, because what I'm doing is that I'm grabbing a fragment that allows me to display the Salmon Forms page. I simply have a new view here that we'll see soon. It says, well, I want you to initialize Salmon Forms. Then subscribe to this message, create a view, and show me the view here. And whenever there's an event inside this view here that's living inside Salmon Forms, I want you to run this code here, right? So we pretty much totally just decouple those two different dependencies, which is pretty cool. And if we look at the shared project and the services, we'll see here that we have the iAccount service. The iAccount service implements the interface iAccount service, which lives inside the Salmon Forms project, right? So what actually happens here is that we inject the implementation for Android or iOS into our Salmon Forms project. And it has no idea about what those two things are really, right? Let's run the app. So I think this is pretty powerful. Like, it allows us to write more testable code. And I think that's the goal here, right? Testable and maintainable code. And hopefully it's a bit more fun to work with. Maybe not fun for our coworkers to debug, but at least we wrote some good code. And I'll just get rid of that. Of course, for some reason it's not working. So let me go into, wow. Let's run it on iOS instead. So what should happen here is that we're now allowed to log into the app. I'm soon going to release you all to get the beers. There's going to be a lot of lines now anyways because someone finished a bit early. So I'll click not now here, hopefully. Right. So I shouldn't click not now, that's why it's not working. Demo gods. Let's click login, which is what I should do. Click login here, we'll get this beautiful white screen here. I'll write Filip. I'll do login here. And then I'll click about here and it says Filip in here as well. So a few things happen in here. First of all, we embedded Salmon Forms and said, well, this view here is now Salmon Forms. We injected the implementation for one of our interfaces, which was implemented in one of our native layers. And then we have a different Salmon Forms view here, which is using that if we take a look at my page here, it's saying, well, give me the account service. And this is a totally separate Salmon Forms view. It's asking for the same dependency, and then we're using that and showing that in here as well. That's pretty cool, right? It allows us to separate all our concerns and write more testable code. And I think that's the end goal here, right? So, one last thing to talk about, and I just want to talk a little bit about MVVM. MVVM allows us to build applications that are separated into a few different types of layers. We have a model that represents our data. We have a view model that allows us to do operations on that data. And then we have the view that simply displays the data. And we write tests, maybe for the view models and services and so forth. And the idea is that we can break all of these things out to make it easier for us to build awesome apps. And there's a few frameworks out there. I'm not saying that there's one framework to rule them all. We have things like MVVM Lite, we have Fresh MVVM, and I'm going to have a look at Prism here in just a little moment. I think Prism is doing a really great job in allowing us to use a framework for the MVVM pattern. So the goal of one of these frameworks is to allow us to do things like navigation, event aggregation, and dependency injection. We saw that we can do this out of the box with Salmon Forms and the dependency service and the messaging center. But let's have a look at how we can do this with something like Prism. So Prism is a pretty amazing technology that's been around for a long time. And I have this project here, and what I want to show you here that's pretty cool is that I want to make it even easier for me to say that, well, this is the view here, this is the view model here. Just figure out how to tie it all together. So what I'm doing here is that I have a Prism reference inside my project. It's a Prism application. And what it's simply doing is that, this is where the mind might boggle a bit, but it's using AutoFac internally. So we're setting up a new container. I'm registering an instance of a type. So what I'm doing here is that I'm doing something a little bit crazy. I'm saying, well, give me the instance from the dependency service for iAccount service and add that to our AutoFac container, which is used inside Prism, inside the Salmon Forms project, right? Which means that whenever I navigate to one of my views, it'll just know how to create an instance of an iAccount service. Is everyone with me so far? Let's have a look at some more code. So what I have here is I have a view called login view. This here is using the MVVM pattern. So the MVVM pattern allows me to say, I want to show this view here. And on a few places, let's bind to the username, for instance. And then let's also allow me to bind to a login command. This view is now totally separate from the view logic that handles these events, right? Which is pretty good. That means that I can work with the view model and do a lot of logic and don't care about the view itself. We never want to go into the code behind of a view and write code in there, right? So inside the view model, this here is now bindable base, which is a thing in Prism. But then we can see here that we have our constructor, which takes an iAccount service. That's pretty cool, right? So how do we inject that? How does our application know how to put in an iAccount service in here? Well, if we look on Android, we can see here that in the activity that is in fact using this thing here, all it's doing inside the login activity is that we're saying, well, load our application. This here sets everything up with Prism. It loads everything into the AutoFac container. It just bootstraps all of those things. It sets up the dependencies and so forth. But then here at the bottom, I'm simply saying, well, give me a new login view and create a fragment. How does this thing here know how to bind to the view model? Well, this is where the magic happens. So inside the SAML itself, I'm actually saying that we want to automatically auto-wire this with the view model. So Prism is going to look for something that's called view model. So it's going to take the name of this view that we're navigating to. It's going to find the view model. It's going to create an instance, and it's going to know that it's taking a dependency of the iAccount service. It's going to inject that because we registered that with AutoFac. That's where the mind blows. Let's run the app. Hopefully this works. So the idea here is that we now have a much more decoupled app, and we're using technologies that we might have used in Salmon Forms projects. We're using Prism that you might also have seen in like old WPF applications. So when I click sign in here now, if this works, I hope so, takes a little bit of time because it's setting up Salmon Forms. Now what's happening here is that it created an instance of our view here. It created an instance of the view controller. It bound those two together, which are loosely coupled. It just found that by the name. It automatically created the iAccount service, injected that into the view model. And then when I write Filip here and click login, we want to set a breakpoint in here as well and see if that's going to work. I'll click login here, and we can see here that we have the username, which is Filip. And of course, we have an iAccount service, which was injected into our constructor just magically by Prism. And then we can send off the login command here. And now what's even more interesting is that if we go into the login activity and put a breakpoint on Android inside the event that's listening for someone completed the login, we'll release the debugger here, and we're getting here. I can check the object that's being injected into our event here. We can see that, well, here's the username Filip, right? So I can use that view model inside Android as well. So all that's showing us that it's really easy for us to separate all these different concerns by using common practices that we've probably been using in a lot of other applications before. So all that this is pretty much giving us, it's a way for us to write more testable apps. The end goal is pretty much write testable, maintainable, and apps that are more fun to work with. Right? So it's simple patterns and practices to make us feel more like this here. We want to be more happy when we're building apps. Right? We want to feel more like these kids that are super happy and proud of their apps by bringing our UI logic into view models, avoid having too much platform-specific code inside our shared projects, and avoid writing too much code in our Android and iOS projects. That allows us to write more shareable code. And it is okay to do platform-specific code where it's appropriate, right? We might end up having an application that's pretty much layered like this instead. We might have a little bit larger iOS project and a little bit smaller Android and maybe a little bit bigger Windows. But that's totally fine. Sometimes we build features in the platform-specific layers that won't ever be available on different platforms. Maybe we use Touch ID on iOS and we build that into the app itself. So that's totally fine. But as long as we try to reach more shared code across these platforms by using principles like a service locator pattern, inversion of control, and using the event aggregation, and so forth, that'll make it a lot easier for us to build these better apps. So pretty much to wrap all this up, we want to look at patterns that help us build better applications. We can look at service locators, and we can use event aggregators, and all those different things that we've probably seen in a lot of different types of applications before. So before you head out to the beers, I want to remember, ping me on Twitter. My Twitter handle is @FEkberg, the same as my company name. Just send me a ping if you want a digital copy of my book. Don't remember to vote on your way out, and if you have any questions, I'll be sticking around for a few minutes here. And thank you so much. I'm Filip Ekberg.